Hello Year 9s, welcome to the first video lecture for the Geology unit for the year 2020. You're at home, or perhaps you're at school being very bored in N block or C block or somewhere with computers. So I'm filming these in order to give you at least as authentic as possible experience that you would normally have in class, but instead of my lovely bearded face cavorting around the classroom, instead you get slides and the occasional hand. And hey, you can see my foot, so there we go, so you can see my knee and my foot. Alright, so there will be references to worksheets and videos. Now you will get access to the videos through e-learning. There is the folder, access to my videos folder there. Any worksheets as well will either be given to you as part of the booklet, or you can access them as well via e-learn. So if you can see this video, you'll be able to access the other online things. So let's get started. If you see a pencil up the top corner, pause the video, write stuff down. Feel free to copy down things and then go back and listen to my voice and jot down extra notes. That can be a good way to help with your studies as well. However, I'm just not going to pause on things to say, oh, I'll wait for 5 minutes for you to write things down. I will just go through the content and you can pause them as you find appropriate. So here's our heading. Let's have a look at the Walt and the Will for this. We're going to start off with simple, what are earthquakes and what are tsunamis? And you should know some major features about these, because this is going to be part of our evidence-based learning for this topic as we put it all together into a puzzle. So why are we doing this? These are some regular events, and they do major damage to communities all over the world. And you may have known people that have been hurt in earthquakes or tsunamis, especially if you have families living out in the Pacific Ocean. These are things that are quite worrisome for certain communities. So, first things first, I want you to brainstorm 10 words that relate to earthquakes. Share your list with a friend. Now, the sharing part, that's going to be a little bit harder, but I have set up a discussion board on our e-learning site. Log into there, share your list through there, and that way we can get some portfolios of words going. Alright, so hopefully you've shared that list. If not, pause it, go do the list now and then come back. So let's continue on. So what is an earthquake? An earthquake is just a sudden movement of the earth. It just means that things are moving. They vary in strength. They go from really tiny microquakes that could be happening right now that you just can't feel because your body's not sensitive enough for it. Or they could be these huge devastating events, the sort of things that we think about and we imagine happening. And a common way of measuring them is on something called the Richter Scale. Now the Richter Scale is a little bit older. There are some more modern versions of it, but the Richter Scale is a good place because anything else is a deviation from that. Now, a Richter scale is what we call a logarithmic scale. So, money is a linear scale. If something costs $10, it is twice as expensive if something costs $5. Inversely, we could also say something that costs $10, we'd expect to be twice as good as something that costs $5. I'm not going to go to McDonald's and pay $10 for a Big Mac. But, I'd probably go to Nando's and pay $10 for a burger because their burgers are better than Macca's. But a logarithmic scale, and you might actually have seen these recently with conversations about COVID-19, a logarithmic scale, the y-axis, and sometimes the x-axis as well, goes up in multiples of some other number, often 10. You can have any different scale across the axis, but 10 is the most common one. And so what that means is that a 6 on a Richter scale is 10 times stronger than a 5. Okay? And so a 6 is not twice as strong as a 3, because there's 3 to 4 to 5 to 6, that's going up by 3 increments, and 10 times 10 times 10. So a 6 is not twice as strong as a 3, a 6 is 1,000 times stronger than a 3. So because these things have such big values if we were to measure it linearly, instead we use a log scale. Now there's a reference down here, you can see down the bottom corner, video what is an earthquake. If you go onto my OneDrive and you can access that through the e-learning website. Go to Unit 2, there is a video link to Mr. Warren's OneDrive, and you can access your, you just need to log in with your student username and your password. I don't see it, but it's not like I couldn't reset them anyway. And then that way you can watch that video there. So you're looking for number 1, what is an earthquake? Okay. And here's a picture of what an earthquake looks like. We'll have a focus where the earthquake actually occurs, and the epicenter is the bit on the surface above the center of the earthquake. You may remember from our layers of the earth last year, you've got your crust, and this is happening here right somewhere within the crust in this tectonic plate, sometimes right at the very top of the mantle. After that first shock, any shocks after it is called the aftershock. Pretty straightforward name. So let's think about predicting an earthquake, and the short answer is we can't. Not perfectly anyway. We know how often they should happen statistically, but we can never say exactly when they'll happen. And there was a issue, it's going on 5 or 6 years ago now, where a group of scientists that worked for the national earthquake predicting area, because Italy has volcanoes, Mount Vesuvius for example, and they get earthquakes, and they were sued for not being able to say exactly how big and when an earthquake would be. They said there'd be one coming because they'd seen signs of tremors and instability. Like, look, there's probably going to be one, but we can't tell you exactly how bad it's going to be. Just be careful. People didn't like the fact they didn't say, well, no, this is going to be really bad. It's going to happen at this time, at this day. So, maybe don't go for lunch on Thursday the 18th. They had a sort of more general thing. And some people died. So they got sued. What do you think of that? Okay, now, there's also a journal that's been activated on there. Certainly have a reflection about this on your journal, or perhaps on the discussion board. I think let's go to the discussion board for this one. That way you can share with the rest of the class about what do you think is the right. Do you think that's right? Do you think that's wrong? What are your perspectives on it? Give it a shot. So, here are some really big earthquakes, and these are just ones I've got pictures from, and they're from the last few years, but huge earthquakes happen quite a lot, and we could find evidence of these, or we can find images that would help you think about some of these from any year in the world. These things happen a lot, but here are some of the bigger ones recently. Christchurch was a particularly heavy year. We had the 2011 earthquake in 2011 was a particularly heavy year. We had a big 6.3 in Christchurch. Christchurch wasn't terribly bad, simply because Christchurch is a more modern city and was built with a bit of fair reinforcement to help, or earthquake proofing in order to help that. The Honshu one was very, very bad. It was a 9.0. And that was the one that resulted in the Fukushima nuclear disaster afterwards as well, that you may have heard about. Nepal, a few years later, over near Mount Everest, and that was a 7.9, so quite a bit stronger than Christchurch, but the fact that the remoteness of it being up in a mountain and poorer communities meant that was quite severe. Now I'm going to show you some pictures of some of those, and there are some videos for them as well. So this is Christchurch, and here you can see the warping that happens to railway tracks, which I think shows a really great example of how severe the earth movement can be. But here with Christchurch, this looks pretty bad. I mean, it's half a building's fallen down, but you can see another building here that looks perfectly fine. And so it stands to reason this one perhaps might be a bit more modern, could have some more proofing against the severeness of earthquakes, while this one here just happened to get unlucky. Now, there is a video of this earthquake actually happening, because Christchurch is a modern city, has a lot of cameras around, and you can access that through the OneDrive as well. This is Nepal. Roads closing, you see a very mountainous terrain, so it's obviously going to be a lot more damaging. But here the buildings got hit quite badly, and they're needing to remove rubble to get people out. It was quite bad. And this is the Honshu one. Unfortunately, this because it was off the coast, not only did they have the earthquake, but then it got hit by a tsunami afterwards as well. And so we had the initial damage from the buildings, and then it got hit by a massive wall of water that came in. And tsunamis don't look like you sort of imagine it from cartoons, and you don't really clue onto it, but if you want to sort of try to get a picture for how heavy or how much force this water goes, get a garbage bag and fill it up with water, then try to pick it up. Remember, 1 litre of water, that's just a milk carton, weighs 1 kilogram, and a garbage bag of water could hold 30 to 40 kilograms, and that's not all that big. From then, if you're imagining millions of litres of water, even if it goes slowish, that's still a lot of mass. That means there's a lot of energy there. Even if it's going slow, it's going to cause massive amounts of damage, and you can see what's happened there. Now, how do we protect ourselves against it, though? Because we've been dealing with this for a long time. So why do earthquakes make some buildings fall down? Like we saw in that picture of Christchurch, there was a building that was half over, then there was a taller building 20 metres away that was fine. Why? And I want you to watch this video and look for these things. Why do earthquakes make the buildings fall down? And what is resonance? Try to explain this topic of resonance. Okay? So I'll give you a few minutes, go watch that, and then come back. Alright, now, hopefully you did watch it and you're just skipping ahead, because it'll really help you if you do. Resonance is the act of something, a regular motion, contributing to the motion of something else. And that sounds really complicated, but the best way to explain it is, think about pushing your little brother or sister or cousin on a swing. The best time to push them is when they've just come back right up to your face. Where's my pen? Let's draw a swing set. So the best time to push them, how do I draw a person sitting down? There we go, is when they're at this point and their motion is at 0, or at least pretty close to 0. If you pushed them when they were here, going forwards or backwards, well, if they're already going forwards, it's kind of hard to give them a push, isn't it? If you push them when they're coming backwards, well, you've got to push back against the motion. If you push them when they were up here and they had no motion, okay, they might go a little bit further, but it's not going to help too much. But if you give them a push here, you give them a little bit more energy, they go a little bit higher, and then they come back a little bit higher. Then you push them again, they go a little bit higher, and they come back a little bit higher. If we were to look at the motion of a swing, it's always forwards, backwards, forwards, backwards, forward. It's getting bigger and bigger every time. And that's resonance. Resonance is adding a little bit of energy at just the right frequency to make things get bigger and bigger. One thing, if you get something like a person on a swing and they don't kick their legs around, the time it takes to go from one side to the other will always be the same. Doesn't matter if it's a big swing or a small swing. If the kid starts kicking their legs and pulling on the chain, the swinging motion, it will change the timing of it, but the frequency of an unassisted swing will always be the same. And so then if you're adding something at the right time, so tick, 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 then it gets bigger and bigger. There is an instruction in most military manuals that soldiers who are marching are not allowed to march over bridges, because if their frequency of stepping happens to be the right frequency for the bridge, it sets up a resonance in the bridge, and this has caused bridges to fall down just by having 1,000 people marching over it. But if you had 1,000 people just walking over it, not a big deal. 1,000 people don't weigh that much compared to bridges carrying dozens of cars, but 1,000 people marching with a in the right unison, the right cadence, can set up a resonance event. Right? And so earthquakes are not about violently shaking something, it's about getting the right frequency of shake, and that's what causes a building to fall down. Now, if a building's pretty poorly made, then yeah, give it a shake and bits will come crumbling down off it. But if it's a bigger building, or if it's a building that's a bit more modern, it needs to be the right frequency to get it to pull itself apart. And so that's what all our earthquake protection goes to fix against it, by either adding some elasticity to it, by a bit of flexibility, by adding counterweights, by isolating it from the ground using basically huge shock absorbers. So there are lots of different techniques to do it. And if you take science and practice in year 11 and 12, you actually get to design some earthquake proofing and test your building design against a simulated earthquake, which is a pretty fun subject. Alright, so where do earthquakes go? Now you're going to get a map of this. A worksheet, if you're studying at school, will either give you one or it'll be on eLearn for you to grab, but I'll try to bring you one around. And you'll notice here they're not random. They are very much located in certain places down the west coast of the Americas, through the middle of the Atlantic, through the Mediterranean, this section here where India connects into mainland Asia, down here through Indonesia and the Philippines. New Zealand there is underneath that yellow. Japan here is underneath that yellow. These locations are important. Now this map is going to be pretty important for you for your not assignment, your exam later on, so certainly sort of keep in mind that earthquakes happen in certain places and try to remember some of those places. There's a great video that shows the mapping of earthquakes for 2011 and places a dot where they are, and you'll see this similar sort of diagram appear. So go have a watch of that, because that's a great video. And don't turn the sound up too loud. So last bit is, what's a tsunami then? If an earthquake occurs underwater, so where if above the ground where the earthquake is there is water, then instead of shaking the earth above it, it shakes the water, obviously. And that creates a wave. Now out in the ocean, that wave might not be very noticeable at all, because the ocean has a lot of waves in it already. But as it approaches the shore, it can get quite large and quite dangerous. And the reason for that is the shallowness of the ground. Okay, so here's the earthquake, bloop, and the wave goes out. But the wave, the depth of the wave is from here to here. As it gets closer to here, you can see that the depth of the water is no longer that big. Okay? And so as the wave approaches, it pulls the water down, but then that wave, that energy for it, gets crammed into a smaller space. And so the wave height gets bigger, and all this water gets pushed forward onto the shore. Instead of having a lot of room to store its energy, it only has a small amount of room to store its energy. And there's a good video down here that you can watch how tsunamis work. Again, go check that on the eLearn. Yeah. And here are our sources for where tsunamis have crashed. Tsunamis that have been recorded around the world, and you might notice some similarities with it and the earthquake map. We can see lots of tsunamis here down the coast of the Americas, down through Japan, Indonesia, Philippines, New Zealand, and then a lot of tsunamis here through the Mediterranean. Okay? Remember, earthquakes have to occur for there to be a tsunami, but earthquakes occur in certain places, so therefore tsunamis should mostly occur in certain places as well. Now, the reason that there is not really that many tsunamis down through the coast here will come down to when we talk about plates and boundaries a little bit later on this topic. Okay. Alright, that brings us to the end of our first video. Okay. Hopefully you got yourself the notes and it helped explain some of the things about it. Remember, email me, email your teachers if you're having problems with learning the topics. It's going to be a strange few weeks, but you just need to give it your best, and hopefully things will be okay. Alright, stay safe kids, and I'll see you soon.